In this video for our algebra review, we're going to look at how we simplify radicals. So simplifying radicals. And there's two parts to this. In this video, I'm just going to talk about what we learned last year in algebra. In a separate video, I'll talk about the new thing for this year, which is about rationalizing denominators. Since that's new content, I want to keep it as a separate thing, so that'll be in another video. For simplifying radicals, remember that a radical is this symbol here that we think of as a square root. It doesn't have to be a square root though. When we draw a radical, it's assumed to have an index value of 2, meaning that it is the second root or the square root of whatever number is inside of here. So if I have 16 in here, I'm looking for what number to this power equals 16. So in this case, it would be plus or minus 4, plus 4 minus 4. Because if I do 4 times 4, I get 16. And if I do negative 4 times negative 4, I also get 16. So this symbol, the radical, is assumed to have an index of 2 if it's not written. But it can have other numbers. So if I had a 3 here, then that means the cube root, or the third root, of whatever number is in here. So if I did the cube root of 8, for example, that would equal plus or minus 2, because 2 times 2 is 4, times 2 is 8. Oh, sorry, cube root is just 2, not negative 2, because if I did negative 2 times negative 2 times negative 2, I would end up with a negative 8. So 2 times 2 times 2 gives me 8. We can actually put any number here for the index, so that just means we're multiplying that many of the number together to make the thing in here. So the way we simplify radicals is kind of reverse engineering. Instead of going from here to here, we're trying to find these paired up numbers, or these sets of numbers, within the number that's in the radical. So let's pick a slightly bigger number. So let's try to simplify the square root of 132, which I don't know off the top of my head how this simplifies. We're just going to figure it out. So remember, since there's no index number, that means this is a square root we're dealing with. In order to find what numbers we can multiply together within this, we factor the 132 into what we call its prime factors, or we look for perfect squares within that one. So I'm going to start off by factoring this as, it looks like there's a 4 in there, so this would be 4 times 33. Is that right? So it was 2 times 66. Yeah, that looks right. So I could then keep factoring. The 33 is 3 times 11. Those are both prime numbers. I can't factor that further. This 4 I can factor into a 2 times a 2. I can also not factor it if I recognize that this 4 is a perfect square. And I can just stop there and say, oh, that's going to give me a 2 that I can release from the radical. So once I've got my prime factors, I look for pairs of numbers. The reason we're looking for pairs is that hidden index of 2. If we were doing a cube root, I'd be looking for sets of 3. Or if we were doing a fifth root, I'd be looking for 5 of the same number. So we're just looking for a number of matching items that equal the index, which in our case is normally going to be 2. So when we find that, that means that this 2 times 2 equals 4. You saw how here, whatever thing we had repeated came outside of the radical as a normal number. So I can bring out this 2, but then the 3 and the 11 don't get to come out because there's no pairs for them. So this 33 gets left behind inside the radical. Let's try a bigger number and do like 540. So I'm going to say I don't recognize any perfect squares within this like I did here, and just start with the fact that this is even. I'm going to divide by 2. And that leaves me with 270 there. This is still even, so I could divide by 2. I also see that it's divisible by 10 because of the 0, or divisible by 3 or 9 because these numbers add up to 9. But I'm just going to go ahead and stick with dividing by 2 because it's even. That's going to give me 135. This isn't even anymore, but it ends in 5, so I can divide that by 5, and that gives me 27. 27 is divisible by 3 and 9, and 9 is divisible by 3 and 3. So I've found all of my prime factors, and now I'm going to look for the pairs of numbers within those. So I have a 2 and a 2, and I have a 3 and a 3. In fact, I have another 3, but it doesn't have anything it's paired with. So I end up with 2 and 3 get to come outside of the radical, and left inside is the 3 and the 5. Once I have all the numbers where they go, I recombine them. So 2 times 3 is 6, and 5 times 3 is 15. So if we went to a calculator, we would see that the square root of 540 is whatever number that is. I'm not sure, 20-something. And then 6 square root of 15, 6 times the square root of 15. Those mean the same number if we turn it into a decimal. So the two numbers we're talking about here are the same thing. Okay, so that's our general process for simplifying any radical, is just to find pairs of numbers within its prime factors and then bring out one of each of those paired numbers and leave behind any single numbers, and they stay inside the radical. So that's a quick review of simplifying radicals. Hopefully that helps jog your memory about how those work.